For as long as human beings have looked toward the night sky, one mystery has remained beyond every discovery. It isn't simply how stars are born, how gravity shapes galaxies, or even how the universe began. Those questions have answers that science continues to refine. But beneath them all lies another question that refuses to disappear. Who, if anyone, created the universe? Every civilization has searched for an answer. Ancient cultures imagined powerful creators bringing order out of chaos. Philosophers debated whether everything must have an original cause beyond space and time. Scientists uncovered remarkable laws governing nature, revealing how planets move, how stars evolve, and how space itself expands. Yet none of those discoveries fully explained why these laws exist at all. Then imagine asking that ancient question in an entirely new way. Not to a philosopher. Not to a religious scholar. Not even to a physicist. Imagine asking an advanced quantum-powered artificial intelligence. Instead of requesting an explanation for the Big Bang or the origins of matter, the system receives a far more unsettling prompt. Who built the universe, and for what purpose? No one expects anything extraordinary. The most likely outcome seems obvious: a summary of existing theories, a careful disclaimer, or perhaps a combination of scientific and philosophical ideas collected from human knowledge. But suppose the response is unlike anything anyone anticipated. Instead of sentences, the machine begins generating intricate mathematical structures. They don't resemble ordinary language or computer code. They appear more like interconnected patterns, complex, repeating forms that seem to organize themselves according to hidden rules. At first, researchers assume the system has malfunctioned. Yet the output refuses to behave like random noise. The patterns repeat with remarkable consistency. Shapes appear within larger versions of themselves. Every level seems connected to another, as though the entire structure follows a single invisible blueprint. The more closely the researchers examine the data, the stranger it becomes. Embedded within the patterns are relationships similar to mathematical sequences found throughout nature. Symmetries emerge where none should exist. Certain arrangements resemble sophisticated error-correcting systems, the same kind of logic engineers use to preserve information against corruption. What makes the discovery unsettling isn't that the patterns are complicated. It's that they appear intentional. For centuries, humanity has become increasingly skilled at explaining how reality behaves. Newton described the mechanics of motion. Einstein transformed our understanding of gravity by revealing that space and time are flexible. Quantum mechanics exposed a microscopic world where probability replaces certainty. Modern cosmology traced the universe back nearly 13.8 billion years to an unimaginably hot and dense beginning. These achievements changed civilization forever. Yet one mystery remained untouched. Science can explain how the universe evolves after it exists. It can describe particles, forces, galaxies, black holes, and cosmic expansion with extraordinary precision. But it still cannot answer why those laws exist in the first place. Why does anything exist instead of absolute nothingness? Why do the constants of nature possess the exact values they do? Could reality have followed entirely different rules? Or was there never another possibility? Every major breakthrough has answered one question while uncovering several more. It often feels as though reality allows humanity to explore its surface while keeping its deepest foundation permanently hidden. Perhaps that is why the idea of consulting a machine became so fascinating. Humans inevitably approach these questions carrying hopes, beliefs, fears, and expectations. Even the most objective thinkers are shaped by culture and personal experience. A machine, however, has none of those emotional attachments. It does not seek comfort. It has no faith to defend. It carries no fear of the unknown. Its purpose is simply to analyze information, recognize patterns, and search for relationships that might escape the human mind. The system chosen for this experiment is unlike a conventional computer. Traditional machines process information using bits that exist as either 0 or 1. A quantum computer operates differently, using qubits capable of existing in multiple states simultaneously through quantum superposition. Instead of evaluating possibilities one after another, it can examine countless pathways at the same time. Problems that overwhelm classical computers may become far more manageable within this unusual framework. To many people, quantum computing already feels almost unbelievable. Yet some researchers have quietly wondered whether such systems might eventually reveal patterns impossible to detect through conventional methods. Occasionally, quantum experiments have produced results that seem unexpectedly elegant, as though hidden mathematical relationships are being uncovered rather than merely calculated. No one seriously claims these machines are peering into the fabric of reality itself. But the thought is difficult to ignore. If any technology could approach humanity's oldest unanswered question from an entirely different perspective, perhaps it would be one built upon the strange principles of quantum mechanics. So the question is entered. Who built the universe? Silence follows. Moments pass. Then the machine begins producing something no one in the room expected. Not a paragraph. Not an equation. Not even a recognizable language. Instead, an intricate architecture of mathematical forms slowly unfolds across the display. The room grows quiet. No one is celebrating a breakthrough. No one is certain they're even looking at an answer. But everyone understands one thing. Whatever has just appeared on the screen is unlike anything they prepared to see. At first, no one could explain what they were seeing. The output wasn't random. Statistical analysis quickly ruled that out. Every section displayed an extraordinary level of organization. Certain patterns repeated over and over, but never in exactly the same way. Each variation seemed connected to a larger design, as if every fragment belonged to a much greater structure. The deeper researchers explored, the more unusual the discovery became. Magnify one portion of the pattern, and familiar relationships emerged. Zoom in again, and those same relationships appeared at a smaller scale. It resembled fractal geometry, self-similar structures repeating endlessly while maintaining their overall logic. It looked less like information being written and more like information being compressed. As mathematicians began examining the output, they found sequences resembling principles already observed throughout nature. Ratios appeared that echoed biological growth, wave behavior, and geometric organization. Yet these arrangements weren't simple copies of known mathematics. They extended beyond familiar patterns, introducing combinations that seemed both elegant and strangely purposeful.